Hey everyone, welcome to Mr. Winter's AP Chemistry videos. I'm Mr. Winter. Today we're going to be talking about isotopes. Isotopes are atoms of the same element that have different numbers of neutrons. So we're going to look at some intricacies and ways that you can maybe get asked questions in your AP Chemistry class. Today you're going to need a periodic table. You're going to possibly need a calculator and a pen and pencil to take some notes. Don't forget, I've linked a graphic organizer down below to kind of help guide your notes for today's lesson. So let's go ahead and get started. This requires a little bit of background knowledge, so I'm going to kind of jump in and remind us all what the atomic number is. The atomic number refers to the number of protons an element has. So if we're looking at this drawing here, excuse me, this element has 6 protons. And you can tell by looking at the top of the box on the periodic table. So that number 6 is a whole number. It's referring to, once again, the number of protons an element has. So if carbon's atomic number is 6, carbon has 6 protons. So that's where we get the atomic number from. So kind of just checking some of our understanding here. Let's go ahead and look at a periodic table and answer a couple questions about the elements from that periodic table. The first one is, what is the atomic number for copper? What is the atomic number for copper? So if you go ahead and look, copper has the element Cu. You kind of look around and you're like, oh, hey, look, Cu is right here. Cu is right here. The atomic number for copper is 29. Remember, that is also the number of protons it has. And that helps us out with the next question. How many protons does lead have? Lead has the atomic formula Pb. Lead is right here, Pb. It is number 82, atomic number 82, which once again also indicates the number of protons it has, the number of protons it has. So all of these numbers, once again, are the atomic numbers for each one of these elements. And the way we identify an element is by the number of protons that it has. So with that being said, what are isotopes and why are they actually important for us? Well, an isotope is listed up here. An isotope is the atom of the same element with different numbers of neutrons. So when we're looking at isotopes, one of the things I want you to identify is the prefix here, iso. This comes up a lot in chemistry, being able to dissect words. Iso means the same. Iso means the same. And so atoms of the same element, that means they have the same number of protons, but they have different numbers of neutrons. So the number of protons cannot change within a specific element, but the number of neutrons can, while retaining its identity. So for example, there's actually two versions of carbon. We have carbon 12, and carbon 13. Now, if you're looking at your graphic organizer, you're like, wait, where the heck are 12 and 13 coming from? Well, these are carbon's mass numbers. These are carbon's mass numbers, which is specifically referring to the total number of protons and neutrons. Earlier, we defined carbon as having 6 protons, so both carbon 12, C12, and carbon 13 have 6 protons. This comes once again from the atomic number, and the number of neutrons is going to be different for each one of these because these are isotopes of each other. So notice that if the total number of protons and neutrons is equal to 12, 6 plus what is equal to 12? That's 6. 6 plus what is equal to 13? That is 7. So carbon 12 and carbon 13 are isotopes of each other. Now, one thing I do want to point out is that the mass number and the atomic mass are different. They are different things in the world of chemistry. The atomic mass refers specifically to the mass of an isotope, how heavy it is. And this is a measured value, so it's never going to be exact. Whereas the mass number is a whole number value, quite literally telling us how many subatomic particles I have. You can't have a half of a proton or a half of a neutron. So the mass number will always be a whole number. The atomic mass will always be a measured number, and they'll sometimes be fairly close to each other. So I want to end today by looking at some examples of natural and stable isotopes. We're going to specifically look at iron. Here's our Iron Man here. Yeah, that's right. Google Draw. Got that on the back of my hand. Um, so here we go. Natural and stable isotopes of iron. There's 4 of them. Each one of these has 26 protons. And the reason that I know that each one of these has 26 protons is because iron's atomic number is 26. But the number of neutrons is going to change based on the mass number. All we have to do to determine the neutrons for each of these is subtract 26 from the from the mass number. So iron, the number of neutrons is going to be iron 54, is going to be 54 minus 26, which is 28. It's going to be 28, a little bit better. 56 minus 26 is going to be 30. 57 minus 26 is 31. And 58 minus 26 is 32. So 28, 30, 31, and 32 is the number of neutrons each one of these isotopes of iron has. So this is going to be kind of important for our next lesson on mass spectroscopy. So make sure you're comfortable with the idea that an element can have different numbers of neutrons. All right, until next time, thanks so much.